Hello friends, welcome back to the channel. Today is day 12 of our Kubernetes series and we are going to discuss a very important topic, especially from an interview and a CKA exam point of view. ConfigMaps and Secrets. In this session, we will cover what is a config map in Kubernetes, what is a secret in Kubernetes, why do we need config maps and secrets in Kubernetes in first place, what is the difference between config maps and secrets, and yes, we will also do a live demo. Finally, we will see how to reference and use config maps and secrets inside a pod or deployment in Kubernetes. Let's start with the most important question, why do we need config maps and secrets in Kubernetes? Now imagine our SH students application connects to multiple external services. For example, it might connect to monitoring service, API listener, authentication service, or some other internal services like XYZ. So obviously the application will need configuration values like monitoring URL, API URL, auth URL, client ID, API key ID, and many more. Along with this, sometimes the application also needs a client certificate or a private key to securely communicate with an internal service. And apart from external service details, every application also has its own configuration file like application.properties or application.yaml file. Now here is the main point. We should not hardcode these configurations inside the Docker image or anywhere, because if the value changes, we don't want to rebuild the image again and again. So to pass these configuration details into Kubernetes pods in a clean and manageable way, we use config maps for non-sensitive configuration and secrets for sensitive data like passwords, tokens, and certificates. That's why config maps and secrets are extremely important in Kubernetes, both in real-world projects and in interviews. So now the question is, what exactly is config map in Kubernetes? A config map is used to store non-sensitive configuration data. For example, let's say we have our SEH students Spring Boot application. This application connects to database to fetch and update student information. Now in typical Spring Boot application, these database details are stored inside application.properties file like database host name, port number, database name, username, password. If we are using SSL configuration, then SSL trust store configuration, key store password, trust store password, etc. Now here is most important point. These values should never be hard coded, because if we hard code them and tomorrow the database host name changes, the port changes, or the username or password change, or SSL config changes, then our application will simply stop working. So the best practice is store these values as environment variables or store them in external configuration files that the application reads at runtime. So how does Kubernetes solve this? So Kubernetes gives us config maps and secrets to store non-sensitive and sensitive data respectively. Now, how does config map solve this problem? So we create a config map inside the Kubernetes cluster. We store values like DB hostname and port inside it, and then we use that config map inside the pod. Now the pod can consume this config map in two ways, as environment variables or by mounting it as a file using volumes. And don't worry, we will do both in the live demo. So if we talk about DevOps responsibilities, in real world organization as a DevOps engineer, we collect these config values from developers or from the database admin team, and we create config maps accordingly. Then we plug them into the deployment. So overall, a config map solves one simple problem: store application configuration outside the container image and inject it dynamically into pods. Now comes the next interview level question. If config map is solving the problem of storing application configuration, why do we need secrets? Because secrets solve the same problem but for sensitive data. For example, database password, API keys, tokens, certificates, SSH keys, trust store, key store passwords. Now the question is, why can't we store these inside config maps? Because in Kubernetes, whenever we create any resource like a config map or a secret, the data is stored inside etcd. And etcd is basically the Kubernetes database. Now imagine if someone gains access to etcd, they can retrieve the data stored inside it. And if database passwords or API keys get leaked, your entire application and infrastructure can get compromised. That's why Kubernetes clearly separates config maps for non-sensitive data and secrets for sensitive data. And when we store sensitive data inside a secret, Kubernetes store it in a more secure way, and it supports encryption before saving into database or etcd. By default, Kubernetes provides basic protection, but in production environments, companies usually enable stronger encryption. And in real-world organizations, we also integrate external secret managers like CyberArk Conjure, HashiCorp Vault Secrets Operator. Sometimes these run as init containers, sidecar containers, or external controllers. So if you are being asked in an interview what are config maps and secrets, what's the difference? So you can answer, config maps and secrets are Kubernetes objects used to store configuration data inside the Kubernetes cluster, so that our applications running in pods can consume that data later. For example, we can store application properties, JSON configuration, or simple key value pairs and then inject them into pods as environment variables or mount them as files. The main difference is config maps are used to store non-sensitive configuration like database hostname, port, app URLs, feature flags, etc. Where secrets are used for sensitive information like passwords, API keys, tokens, certificates, and SSH keys. Secrets are stored in Kubernetes as base 64 encoded values, and in production environments they are usually protected using encryption at rest in etcd or external secret managers like Vault. Now let's do some hands-on so you understand this concept clearly. Let me take you to the IDE. Here under day 12 folder you will find all the config map and secret related YAML files. Let's start by creating a config map. Let's create a YAML file, new file, sh students -cm.yaml. Just like any other Kubernetes resource, here also the first three sections are same. Those are API version, kind, metadata. But instead of spec in config map we use data, because config map is mainly used to store configuration data. We can confirm the resource name and the API version from kubectl command using kubectl API -resources pipe grep cm. So here kind is config map, cm abbreviation is cm, API version is v1. Now let's fill the details. API version v1, kind is config map, metadata need to provide the name is sh students cm, and under data here I am providing database hostname and port for now. So db underscore hostname colon hostname and db port is 3306. So here I am storing just two values for now, db hostname and db port. Since I am using git, I will push the changes using git add dot git commit -m cm for sh students git push. Now on the Kubernetes control plane node, I already have the repo cloned. First I will pull the latest changes using git pull command. Now I will go inside day 12 folder Now apply the config map using kubectl apply -f manifest file name. So you will see ConfigMap SEH student CM created. Verify the config map using kubectl get cm command. So SEH students -cm created, and see the full details using kubectl describe config map and then config map name. So here you can clearly see the entries for DB hostname and the DB port. Similarly, we can store any number of values inside a config map, and not only key value pairs, we can store complete files like application.yaml, .conf files or JSON files, etc. We already have a deployment running for SEH students application. If I run kubectl get deploy and kubectl get pods, we can clearly see 2 replicas are running. Now if I want to check the environment variables inside a pod, I can run kubectl exec -it, then any of the pod names -env. And as you can see, right now we only have the default Kubernetes and the container related variables. There is no DB related environment variable yet. So till now the application hasn't have any database information. Now let's assume this application needs to connect to MySQL database. So we need to pass the database details like DB hostname and DB port. And we already stored these values inside our config map, that is SEH student CM. So now we just need to modify the deployment YAML. For that I am copying SEH students deployment.yaml from day8 directory to day12 one. So inside the container section, after this ports, we need to add environment block. This means we want to read values from the config map and inject them as environment variables inside the container. So here need to provide -name db underscore hostname. So here name is the environment variable name inside the container, and the value from where name is SEH students -cm and key is db underscore hostname. So ConfigMap keyref.name is the config map name, that is SEH students -cm, and the key must be exactly match the key inside the config map, so that is db underscore name. So here also it is db underscore hostname. The same way for db -port. So -name db underscore port. Config map keyref is the config map name, and the key must exactly match the key inside the config map, so that is db underscore port. Now save the changes and push them into GitHub first, and then in Kubernetes control plane clear the screen and pull the changes using git pull. So now apply kubectl apply -f SEH students deploy.yaml. You will see deployment.apps SEH students deployment configured because the deployment already exists. Now check the pods using kubectl get pods. So pods got created 11 seconds and 14 seconds ago. Now go inside any pod using kubectl exec -it and pod name -env pipegrep -i db. So now you will see db underscore hostname and db underscore port. This confirms that the config map values are now successfully injected into the pod. So now inside our application.properties or application.yaml, whatever you are using, here we can simply write, instead of passing or hard coding the host name and port number, we can provide db underscore host name and a db underscore port. Now let's say tomorrow the database port changes. For example, earlier it was 3306, but now it becomes 3307. So we update our config map, clear the screen, kubectl get cm, kubectl edit cm, SCH student cm, update the DB port to 3307, save the changes. Either we can update the values using kubectl edit command, or we can update it here in the YAML file, push the changes and apply the config map using kubectl apply command again. Kubectl describe config map and then config map name. Here we can see value got updated to 3307. Now the question is, will this updated value automatically reflect inside the running pods? And the answer is no. Not when you are using environment variables. If we inject config map values as environment variables, then the values are loaded only once when the container starts. If the config map changes later, the running container will not automatically pick up the new value. So basically, for environment variables, config map update requires pod restart. So if I check the pod again using kubectl get pods and then kubectl exec -it pod name -env pipegrep -i db. So you will notice db port is still showing the old value. Now if I restart the pod using kubectl rollout restart deploy and then deployment name and do kubectl get pods. So after the new pods come up, again if I run kubectl exec -it and then the new pod name, now you will see DB port is updated to 3307. In production, it's not always a good practice to restart pods every time configuration changes, because frequent restarts can lead to downtime, connection drops and service instability. So Kubernetes gives us a better option. Instead of using environment variables, we can mount the config map as a volume using volumeMounts. And when we do that, config map updates can reflect inside the pod without restarting the container. So now instead of using config map values as environment variables, we will use them as files using volumeMounts. That means Kubernetes will take the config map data and automatically creates file for each key. So DB hostname and the DB port will become files inside the pod. Let's see how to do that. First, I will create a copy of deployment file and rename it -volume.yaml. Now to use volumeMounts, the first step is we need to declare a volume under the pod spec. Remove this one. Here create volumes and then name any volume name, for example db connection, and then config map and name of the config map. Here we are creating a volume and telling Kubernetes this volume should read data from config map named sch students -cm, which we have created earlier. Now we mount this volume inside the container using volumeMounts. volumeMounts. So we are mounting the ConfigMap volume inside the pod inside /opt/db. Now Kubernetes will automatically create files like /opt/db/db_hostname and /opt/db/db_port, and the content of these files will be 192.168.0.16 and 3306. Now save the file and push it to Git. Then on control plane, clear the screen, git pull and apply the new deployment using kubectl apply -f configured because this deployment already exists. And if I run kubectl get pods are recreated 10 seconds and 13 seconds ago. So now if I run kubectl exec -it, then pod name --environment pipegraph -db, you will not see db_hostname and the db_port because now we are not using environment variables. Instead, check the mounted files using kubectl exec -it pod name and then --cat/opt/db/db_port. You will see the db port value here. Same we can validate for db_hostname. So this is the value for db_hostname. If I do kubectl get ConfigMap and edit ConfigMap, kubectl edit ConfigMap and update the db port value to 3308. ConfigMap edited. If I do kubectl describe ConfigMap and then ConfigMap name, value got updated to 3308. Now if I do kubectl exec -it and then db port value, it will take some time. So now it got updated to 3308 without even restarting the pods or deployment. So if an interview you are asked, if ConfigMap values are changing frequently, how can a pod use updated values without restarting? So you can answer this. If ConfigMap values change frequently, we should mount the ConfigMap as a volume using volumeMounts, because when ConfigMap is mounted as files, Kubernetes updates those files automatically inside the pod. For example, here for db port and for, so the pod can read the latest values without restarting. So that's all for today's session. In the next video, I will demonstrate how to create secrets and how to use them inside pods. If you found this video helpful, don't forget to hit like, share it with your friends and subscribe to the channel. See you in the next video. Until then, happy learning.